Hello students, I am Kausalya. Today we are going to solve this example 1.10 part 2. That is, I am going to draw the free body diagram of mass M2 and M3 in this video. So, to draw the free body diagram of mass M2, as usual, just count the number of elements which are connected with M2. So here in this case, this is your M2. So just count the number of elements 1, 2, 3, right? So totally there will be 4 opposing forces, that is K23, B23, B2, and apart from that M2 will also provide some opposing force, right? So now I am going to write the respective expressions. So here Fm2, Fk23, Fb23 and Fb2. So again by Newton's second law, just we are going to make it applied force is equal to your opposing force. So here there is no direct applied force. And here the respective displacement of M2 be x2 and its velocity be v2. So applied force is equal to 0, which is equal to Fm2 plus Fk23 plus Fb23 plus Fb2. Just substitute the respective values here. So that is nothing but M2 into d square x2 by dt square plus K23 into, again this K23 is connected between M2 and M3. So as we are considering M2 here, we have to write it as x2 minus x3. So K23 into x2 minus x3 plus again B23. So B23 is nothing but again it is connected between M2 and M3. So here we have to write it as x2 minus x3. So B23 into x2 minus x3 and finally Fb2. This B2 is connected between M2 and M1. So here I have to write it as B2 into, here d by dt of B2 into d by dt of, here I have to write it as x2 minus x1, right? So again here I have to replace displacement in terms of velocity. So while rewriting we will be having 0 equal to M2 into, again d square x2 by dt square can be written as dv2 by dt. Plus again K23 into integral of x2 minus x3 can be written as v2 minus v3 into dt plus b23 into again v2 minus v3 plus finally b2 into v2 minus v1, right? Name this expression as b and this expression as 2, right? This equation number 2 is the differential equation governing the mass M2, right? And the next one is free body diagram of mass M3. As usual, just count the number of elements connected with it. So here we are having M3. So just count the elements 1, 2, 3. Totally 3 elements are connected with it. So 4 opposing forces will be present, including opposing force produced by mass M3. So here just write down the expressions Fm3, Fk23, Fb23 and finally Fb3. So again by Newton's second law, here applied force is equal to opposing force. There is no applied force here, and opposing forces are Fm3, Fk23 plus Fb23 plus Fb3, right? Here the displacement produced by this M3 will be x3 and its velocity will be v3. So just substitute the respective values. So M3 into d square x3 by dt square plus K23. Again this K23 is connected between M2 and M3. So here we have to write, we are drawing free body diagram of M3. So here we have to write it as x3 minus of x2. So K23 into x3 minus x2 plus again B23. For B23 we have to write it as again x3 minus x2. And finally Fb3. This B3 is connected between, so from the diagram this B3 is connected between M3 and M1. So here I have to write it as x3 minus x1. So x3 minus x1, right. Now just again replace displacement with velocities. We will be having 0 equal to m3 into dv3 by dt plus k23 into integral of v3 minus v2 into dt plus b23 into v3 minus v2 plus finally b3 into v3 minus v1. Let this be expression number C and let this expression be equation number 3, right. So here we had finally obtained the differential equations governing the mechanical system, right. That is your equation number 1 and equation number 2 and equation number 3 are the respective expressions for obtaining the differential equations of the mechanical system shown here. Okay, thank you.